Okay, then. Demagnetizing. Let's see. When we demagnetize something, is it absolutely demagnetized?
No.
It is reduced to an acceptable level, which is generally less than 3 Gauss. Or 3 Orsteds, or 0.003. All right. So part should be demagnetized, I said, between shots. So what we were talking about is I like to do a head shot first and then a coil shot. The reason why I do a head shot first is because
you like to do it
generally.
It's easier to detect that it's been demagnetized.
Because in a head shot, you cannot easily detect the magnetic field. So if we were to do a head shot last, we wouldn't really be able to detect a field, and then we demagnetize it and go, I guess it worked. Didn't have field before, and I don't have one now, so there we go. So that's why I would like to do, I should say it this way, finish with a coil shot, because that is going to give me a detectable amount of field, which I can then demagnetize. So the problem with that becomes when we're using longer things like a crankshaft or a camshaft where we're doing multiple coil shots. I don't like to demag with multiple coil shots. I put it here and demag, move it and demag, because the coil doesn't have an effective width for the whole thing, right? So I like to demag using the head shot on that one. I just feel it works a lot better. But if I had something like a piston pin or something, and I wanted to do, I did a coil shot on it, and I finished with the coil shot, I will absolutely finish a demag with a coil shot. So there's a couple ways that it can be done, depending on the equipment that you have. So the booth that I had, I could put it in the coil, just like this one, hit the demag switch, bump it up just a little bit, right? Because we always want to go a little bit higher than the magnetism we had. So if I magnetize it on a 5, I'd go 5.5, lay it down in the coil so it's good contact. In fact, I should show you this. It's actually a lot of fun. If you put several of them in there, they will roll up and come down and smack each other on the way down. They go. So it's fun. Not good for the part. But so anyway, laid in the coil, several of them. If I'm actually doing real parts I don't want damaged, I'll hang on to them. Hit the demag button. It starts out high, it automatically works its way low and demags it. On the machine that I had, I could lean into the bar and energize the coil, and it's just now on. And it'll be on for as long as I want, leaning into that bar. And so I could take the part in, and what I would do is just kind of tumble it around next to the coil and move it around until I was arm's length away, and then I would lean off the bar and then put it down at the end of the booth. It's going to fall. So another way you could do it is a lot of, I should have thought about this. A lot of shops, I have no idea. There is also just a standalone AC coil where you have, like the one we had here, it's had a timer on it. You can set it for like 10 minutes, just turn it on. It'll be on for 10 minutes up there running and making this huge hum. And it was just a big AC coil, and it had a little bed on it. I think I have a picture of one of them at least. Let's see. All this stuff. I had a picture of one somewhere. There we go. So it's not a Magnaflux machine or a magnetic particle machine. So it's got a little bed right here with rollers on it. And you just roll the part through, bring it out, walk away from the coil, then shut the coil off. So if you put it in the coil and shut the coil off, you just magnetized it. So it'll be magnetized to whatever strength the coil was. So that's basically 3 ways of magnetizing using a fixed bench. Don't look at these.
That coil would be AC, correct?
That is correct. On our machine, even if you magnetize something on DC, when you hit the demag button, it automatically switches up to AC. Let's see. Where did I leave off here? So I said, failure to demagnetize after headshot or coil shot can lead to vectored magnetism. Not true if the magnetizing force of the second shot is more than the first. If you can guarantee that you did a headshot and the magnetizing force was, well, we'll have to use a term like Gauss, like 30, and then you did a coil and it was 40, if you could guarantee that, then you could get away with not demagnetizing. But if you can't guarantee it, I wouldn't do it. Yes?
What would happen if you were to, say, install a crankshaft and it was circularly magnetized?
Okay, that's a good question. That's kind of where I was going next. So thank you for bringing that up. So let's say you install a crankshaft and it has magnetism, circular or longitudinal. It's going to attract iron filings that are going to stick to it. So instead of being washed out of the oil, it's going to want to be in there and not go away.
Like clog up the...
It's not going to clog it. In my mind, you always have metal in the oil, and so you want it to wash out with the oil and go to the oil screen. In this case, if it's going to stick to the crankshaft, then it would stick in where the crankshaft and the bearings are, and then scratch that all up, and you would have reduced engine life by a long shot. I suppose somebody could also argue that having a giant magnet out front is going to mess with your compass.
Yes.
But at the same time, I do have 2 giant magnets in front of my compass. They're called magnetos. So, and an alternator. So, who's to say? But in theory, it collects the iron particles, and that's not good for it. Let's see.
They want you to turn on your prop de-ice, it messes with the compass.
What's that? They tell you
I
that?
said, and yet they warn you if you turn on prop de-ice, it messes
Well, radios and everything too, because you have a compass correction card at your compass, and it's got a little checkbox: radios on, radios off. So, let's see. I wrote 2 ways to demagnetize. Let's see how that's going to work out for me. Let's see. Well, we have a decreasing. I wrote decreasing current with machine. And that is with the step down demag function. I will add this. If it's an AC machine, then it is just decreasing AC current. If it's a DC machine, then it has to be decreasing and
Switching polarity.
reversing and diminishing. I already said that. Decreasing and reversing. All right, let me see. Principle is that the machine will automatically apply the next level down magnetism until the part is magnetized at the lowest level. DC machine magnetism reversed. Yeah, I said that. What we want to think about is that hysteresis loop. Remember the old hysteresis loop? You're like just nodding. Gosh, please don't make me look at that. There we go. So we have the current down here. Current down here. So we're going to magnetize it one way, magnetize it the other, magnetize it this way, bring it down a little bit. So it's going to bring it in. So as it magnetizes that, then it's going to bring the residual down a little bit less, residual down a little bit less residual, less residual. So we're going to, just until we're basically magnetizing it on the lowest setting is really what we're doing. Follow? All right. I don't know, Cooper. It's just as quiet today as it was yesterday. What's up, man?
My brain's trying to catch up.
Oh. Probably not something that's going to happen anytime soon, is it?
You don't see the smoke coming out of my ears already?
Let's see. Oh, my notes are now off. off. It is impossible. It's impossible to completely demagnetize a part. Sort of, unless it is heated to its Curie temperature. I bet that's named after Madame Curie.
They're probably like eating Indian food and they were like, this is curry temperature right here.
It's a Curie temperature, which is roughly 770 to 1390 degrees Fahrenheit. And cool. And an east-west orientation. Yes, that is actually a thing. If you leave a part sitting north and south, which would be this way for the challenged folks in the room, it will remagnetize a part.
It's weird.
Who could have possibly done that?
And you know I'm serious because I wrote it down. If it was a joke, I would have just said it. I wouldn't have wasted the time to write it down.
But it seems so convoluted. Like, look at the moss on the trees, and that's the direction you have to put it in.
I was just well, have your Muslim buddy. All right, which way's east?
They know. I guess this shouldn't have been a number 2, but whatever. Because number 2, because there's 2 ways to demagnetize, would be the large AC coil, which I talked about. But you put it in an AC coil, and anytime you're using a coil and you have it in your hand or it's loosely held, tumbling it and scrambling it makes a difference. It really does help.
Why is that if they don't do that? One shouldn't.
Why do you tumble it and move it?
Yeah,
It scrambles the domains more.
Okay.
It kind
a
of
headshot that doesn't.
it's stuck. It can't.
Yeah, I know you. But
All it can do is follow that hysteresis demagnetizing curve. So it just demagnetize it to the lowest setting. But when you're moving the part around, then think about as you're moving it out of the coil, it's diminishing and it's reorientating it. So you have some pieces that are orientated one way and some another, so it really does a good job. Let's see, tumble, let me see. I'll make that up. Tumbling the part assists in demagnetizing. All right, so that's our basic operating principle for really all of MagnaFlux, but see, I said it again, magnetic particle inspection. But now we can look at some of the other smaller systems. Look at the yoke, which is that portable device. The yoke. I yoke you not. Let's see. All right, the yoke, which everybody got a chance to experience, I believe, in our lab. So the yoke is this direct or indirect magnetization. All right, in the bench, is a headshot direct or indirect?
Right.
Why is it direct?
Is
Touch.
in contact and the cone and the current is flowing.
Not touching. What is the big difference?
One is
the coil. The coils are around it. It's like that's the coil
current
shot. It's
flows
the coils
either
are
through or around.
electromagnetic induction versus
Where the coil is on that thing.
Completing the circuit. Explain completing the circuit.
It's
electrons flow directly through the part from the negative to positive.
Is that what you're trying to say?
exactly.
Okay.
It's hard to say that.
Yeah.
So, in direct magnetization, current flows through the part. So think about the bench. In a headshot, completes the circuit. Current flows through the part. What are the dangers of that?
Overheating it.
Heats up the part, Arcing is the biggest danger because they don't get that hot. They warm it up a little bit so your hands aren't cold. All right, so, and a headshot is direct magnetization because the current flows through it. That is what kind of magnetism? Longitudinal. I don't know about that. I'm going to go with circular on that one. So let's try it again. A headshot is circular magnetization, and it is also direct, and so I say direct and circular. The coil, on the other hand, how much current flows through the part when it's in the coil?
None.
So that is indirect, and it produces, the big circle does not produce circular magnetization. Right? That's how I say it in my head. It just tells you how stupid I am. So I literally say that. The big circle does not produce circular. Oh, it's longitudinal. All right. So now we have a yoke. And the yoke has a coil wrapped around a
Soft iron core.
soft iron core is the word I was looking for. Thank you.
Ding ding.
How much current flows through the soft iron core?
None.
Absolutely none. So if no current is flowing through the soft iron core, that is direct or indirect? Indirect. So using the same thing that we've already learned, if it is indirect magnetization, it is closely resembled to a coil or headshot. Coil shot, then it must be what kind of magnetism? Longitudinal is correct. All right, going back to the bench, we put something in a headshot. Which way do the discontinuities cracks show up? This way, parallel to the current. If we have a coil, which way do the cracks show up? Still parallel to the current because the cables come in and wrap around this way and the current goes that way. So this would be parallel to the current, right? Holds true. Which way would the indication show up? Parallel to the
Coil.
current in the coil. Therefore, the indication would go this way. Because you have to remember this because when you're doing this, it gets a little difficult. And this can get even more confusing to just look at this, and we'll compare it to prods in just a second. But you look down here and you look at the magnetism that is produced, and you say, well, that goes in a circle, but it's really longitudinal. It doesn't. I think it just goes across, and then this goes out like that.
Lines of flux are bigger, so it's longitudinal.
Lines of flux are bigger, sure. I don't know about that. If it works in your head, I'll go with it. All right. So a yoke. Let me see. Yoke. Yoke is a handheld device that uses an electromagnet. Let's see. Handheld device. That uses an electro. What's an electromagnet?
A magnet caused by current.
Magnet that is caused by what?
Electricity.
Electricity, current flow. Typically use 110 volt. Newer ones may use 220. So now you got to unplug the dryer to use it. It's annoying. May have 2 settings. What would those 2 settings be? On and off. No.
Okay, so 4 settings.
Yeah.
In the ON position, it would have 2 settings. And those 2 settings be, what did you say? AC and, yes, DC. What's HWDC mean? Half wave DC. Okay, so we have our choice. What would AC be best for?
Surface indication.
Okay, surface. Somebody stepped on a duck. All right. Half wave DC would be best for. Okay. Which one is more sensitive?
AC.
AC on surface.
Well, why is it more sensitive? Sensitive means it will pick up cracks or indications easier. Why is that?
Because
Because I got that part down.
I'm trying to think of the word.
Because it is.
Motion of the particles.
Ah, because of motion of the particles. Because AC causes media to dance. However, I say that, but half wave DC also does it. So half wave DC is going to have some higher sensitivity than straight DC. So that it's not all or nothing on that one. As I think about it, cause media dance, which increases mobility.
That's the word.
Particle mobility. But I want to say DC is also pretty good at that too. So I don't want to leave you thinking, oh, well, that's definitely what it is. But you've been in the lab and you've heard it. It buzzes and you actually literally see that happening.
I think you lifted it. The plate just went.
Because remember, half wave DC is pulsating, right? Because you're taking a sine wave and it's going to look like this. Just like that. Thank you for playing along. So pulsating, but not to as much of an extent. Let's see. So how does it actually work? All right. The field induced in the internal coil travels down the legs. Travels down the legs. The articulating legs, I could put, and induces magnetic field in the part. In the part. So as we said before, it is indirect. That makes it circular or longitudinal?
Longitudinal.
Makes it longitudinal. I wrote magnetism is parallel to the legs. I don't know if I like that one. Because there's two legs. What is parallel this way? So I'm not going to say that.
Parallel to the.
Discontinuities will show traverse to the legs. So I don't like either one of those statements.
Perpendicular to your hand.
Yeah. Yeah. Just going to leave it. Can use wet method or dry powder.
Did we talk about what the sensitivity rating was for wet continuous MT?
It doesn't work like level 1, 2, 3. It just is.
It is.
Yeah.
It is sensitive.
It is sensitive. All right, so I have in my notes right here, more sensitive, dry powder is more sensitive than wet due to particle mobility. Particles move easier in air than in fluid, but I have some other notes from NDT class where I wrote in wet is more sensitive than dry. So
Wet is probably more visible because it kind of stays there.
yes, so I would look at it like this. Perhaps that's true, and I'm not going to write it. I'm just going to let you kind of think about that one. I want to say there was a test question that actually had dry being more sensitive, and that's where I think I got this from, and I just forgot to erase what the guy said. So that stands to reason that if I have if I have a yoke, let's compare yoke to yoke, apples to apples. Although it's easier to compare apples to oranges because one is red, one is orange. One has a peel you can eat, one is so. I don't know.
You can eat peeled and orange.
You can. You're right. You can eat anything you want to.
Who would eat the peel?
Okay, if you compare the two, you have the same everything set up, and one has dry and one has wet. So you guys, I think with every group, I used the aerosol can that had the prepared bath in it for black light.
Yeah.
All right, so doing the same on each one, I could see how dry powder would be more sensitive and what I would choose for doing a yoke inspection on a flat plate or something, because you would energize it and you hold it on wet continuous, right? You're just going to push the button and it stays on. And then you would take the dry powder and kind of, you're supposed to fluff it on. You're supposed to create a cloud. You're not supposed to shoot it out the part because you shoot stuff right off, but you're supposed to make a nice little cloud that settles down upon it. And so that would be one thing. And I could see how the particles would move and kind of shake to line up with the line. However, if I spray it on, you're not going to get particles to flow from out here, all here. Oh, they just don't do that. So, something we can try tomorrow. We can pull it out and just see what, I haven't done it, and see what it looks like. And see how we like it. But I would say that in that case, dry powder would be more sensitive to a crack. Now, if I take the same theory, now you have a bench, like, okay, I've got a cracked crankshaft, and I'm going to try it with a wet method, and then I'm going to try it with a dry method. It's like, good luck with the dry, right? Because it's got I think you're going to have a harder time just physically getting it in there, especially in a 360-degree pattern. So depends on what you're doing. So ACDE. Let me see. Well, because it is low strength, dry powder is typical. Typically used, and because dry powder is more sensitive. I'm going to go ahead and write it. Dry powder is more sensitive because particles move easier in air than in fluid. And this is generally used with continuous. But the continuous here is a little different than the continuous with the bench. So on the bench, it's a misnomer, right? You put the fluid on and then stop the fluid and hit the button. Remember that?
Yeah.
Good. And so this one, continuous, literally means hit the button and leave it on while you're putting the powder on. So
Seems like this one came out first then.
I would think so. So yolk is energized, and particles are applied by dusting. You have to be careful because if particles have velocity, they may pass by the discontinuity. That would be a bad thing.
I guess how I kind of thinking about it is dry powder has a theoretical higher sensitivity, but to get to that point, it's harder, and so thus wet continuous is just much easier to attain.
Nice way of saying it. See, a small handheld blower. Now, if you wouldn't have seen me do it, I know all of you would be thinking right now, it's just this little tiny, and you're like, you're using it for your leaf, but it's a little
The snot puller. For a
snot
baby.
puller, that baby. Yeah, that's what I said. But most of these guys wouldn't know because they don't take
I
care of
don't
baby.
know,
What's
but
that?
my mom uses it on me still.
Like a baby, just like he said. All right, blower. What about it? Can be used to move particles. Let's see. Yoke is then demagnetized. Or U is turned off, de-energized. Part is examined. Oops, I didn't want to put H. That should be like 3. I. And then part is examined. Part. Examined. Then, the point here is a yoke can be used to demagnetize. And how would I do that?
Pull it away slowly.
All right, we can do diminishing AC. Well, it's only got a AC, DC, and a push button. So how am I going to diminish the AC? Pull it away. Turn it on, lift off, and go away, and then turn it off. So make sure you're far away when you turn it off. Let's see. So we could pull yoke away slowly while energized, or pass part between the legs. Not your legs, but the legs of the part. So if you kind of set them up like this, the magnetism is going to go through it and pass it right through. So it'd be like passing it through a coil. Or reversing, diminishing, DC. Well, how are you going to do that?
Lift it up and twist your wrist a bunch.
Yeah, that's exactly it. Back and forth. I suppose you could energize it, lift it up, turn it, energize it, lift it up, turn it, energize it, lift it up, turn it, energize
Or
it.
you hold, one person holds the part down.
And they do this while they walk away.
Yeah, or you just throw it on Lazy Susan.
You see spinning it. Okay. Let me see.
What's this system in here? Oh yeah, that's talking to you.
All right, so we got that. I took these shots. These are my photos. So there's one application right there, a little duster. Try and dust the particles out on it. You want to use a contrasting color, something that you wouldn't want to use a silver on that, right? So using red because it contrasts with the bare metal. Or you could use, there's white, there's blue. So which way would the indication show up? A or B?
B.
Very good, B, yep. And right there you can clearly see the indication. You cannot.
I can't.
Right there.
It's so bright here.
No, right there.
Right there. I didn't know I could do that.
Where's that controlling
Yes.
Whoa.
I know I could do that either. Look at the cool pattern that it left. Lines of flux are leaking out.
then? What were you doing there? Controlling the mouse?
Yeah, control a mouse scroll. All right, we already saw that. Okay, then there are permanent magnets. So it's the green things. There is a cable between these permanent magnets.
No drugs.
They're there for two reasons now. One, self-defense. What do you think the other reason is there for?
So you don't lose
That is a good guess because knowing this group.
Where's the magnet? I don't know.
Pipe bomb?
So you can pull
I don't know for a fact. I have my theory. So self-defense. So you don't lose one. These are both valid reasons.
for diminishing magnetism, you can pull the part. Is that
I
where
don't
the
think
magnet
so.
off the pipe?
No, I don't. Because you just lift it up like that.
It looks so poorly photoshopped.
Except it's real.
I took that photo. Okay, so it's just enlarged too much. I stole it from something. Would you like to hear my theory?
Sure.
It goes right along the lines of you would lose them. If you notice the length of this cable, which would just finish up that little loop, it is physically impossible to take them and do this with it. And I believe that's literally why they're there. And possibly another reason to limit how far you can go apart so it keeps it within the reasonable limits of what they're designed for. But I honestly feel that the number one reason, now I feel like it's so you don't lose one, but is so you don't turn them and do that because they are so freaking strong that I think you would snap it together and crack and break them. And so
And the cable is
prevent
stiff?
it's not stiff, but there's not it's not long enough.
The full parallel.
Huh?
Yeah.
Give me a pair of dikes, I can do it.
Very tight. No, it's
I gotta wait for.
The way it was
the power of military stupidity.
One person take one, the other person take one, run. Come back.
no, 2 of 1.
So you just get another set of them and then do
That
it.
was to give you some time.
Is this direct or what is it? Powerful magnets implanted medical as pacemakers? All do not use. I guess you can use it with a pacemaker.
No pacemaker. I gotta start my.
I listen to Dateline on the way home all the time. I've yet to hear that one. They killed them with a magnet on their pacemaker. So,
Honestly? Oh man, that's a good idea.
okay. So is it direct or indirect?
Indirect.
Indirect. So that is just like the yoke, right?
Same exact.
And so which way did the crack show up?
That way.
This way up to 45. So really not seeing it very well right there, but we can see it right there. There we go.
Not even yoke, just carry a whole load of
Big enough track to see it.
magnet.
It's the cracks, yes, to show the audience where the parts are.
Okay.
The cracks.
So we got that. What about the yoke then? Yoke. No, we're at permanent magnets. Oh, you know what I forgot to do? I should do process control on the yoke. So what am I process control for the yoke?
Testing
The amount of light.
Okay, so we have to have light considerations. What about light?
having enough visible.
So if we're using the dry visible particles, we must have
1,000 lux or 10.
visible particles. So light, visible. We must have how much visible light to do visible inspections?
1,000 lux.
You got 100-foot candles back there too?
Or 100 FCs. Okay. What if we were doing the fluorescent?
Less than 20.
What is the white light?
1,000.
Less than
20
Less
lux.
than 2 foot candle.
Candles 20 lux.
2-foot candle / 20 lux. What about the black?
1,000 microwatts per square centimeter.
What? At 15 inches. At 15 inches. What about the white light? Where do we take that at? 15 inches from the light?
At the source. At the
Source.
source.
Yeah.
At the test.
Right here.
Yeah.
At
At inspection
test
area.
surface.
Inspection area?
For the visible, at the surface of the part being tested. At test surface. And then the 2-foot candles will be in the area of. All right. What about yoke strength?
Oh, it's like 30 pounds for DC and 10 for AC.
Yeah. So you have to make sure that your yoke is producing enough strength. Let's see. I didn't write it in my notes, but it's 15 pounds. Let me see. 10 and 30.
Yeah.
That was like 3 inches.
Let's see. Etching, vibro, determination, wet particle contamination. Was it there? Dead weight check.
Yeah.
Yokes and permanent magnets. This is going to count when allowed. What does that mean, when allowed? Means you only test it when it's allowed? It's when you're allowed to use them. Shall be dead weight tested at intervals stated in Table 1. I think it's, I forget what table. Alternating current yoke shall have a lifting force of 10 pounds. So yoke strength. So AC is 10 pounds. With a 2 to 4 inch spacing between legs. 2 to 4 inch spacing. What if you stand with your feet together? Does it matter, Kevin? Okay, that is the spacing of the articulating legs, not yours, just to be
My
clear.
legs are articulating.
Not going to be if you keep it up. Not by me, mind you, but so I couldn't do anything about it.
Give it like 5 years, I'll be a
Let's see. DC yoke shall have a lifting force of 30 pounds to 2 to 4 or 50 with 4 to 6. So 30, 2 to 4, 30, 2 to 4 inch spacing, and 50 with how much? 46?
426.
Yeah, 426.
4 to 8. All right.
Yeah, they're right there.
So we got to check that, and I think that was all. 50 minutes. Yep. So we got to check that. So that's our process control on that. Oh, figure 1. How often do we have to do that? There it is. That is not the figure one I wanted. There it is.
Did we check 6 months?
Every
for wet particle.
ammeter, timer, we got black, ambient. So every day we do black light, every day ambient, every day visible, system performance, use the test ring or ring specimen every day. So what is this right here? System performance using the test piece or ring specimen. What's a ring specimen? Ketos ring. Wet particle concentration we check every
8 hours
or
or
shift.
change.
Like, water break test, wet particle contamination, equipment calibration check, Gauss meter, ammeter, dead weight check. There it was. It's what you said. 6 months. 6 months. Seems a little like. I feel like I'd want to do it every time I used it. What happens if you get to the 6 month period and it doesn't pass?
You check everything you did.
How far do you go back and go, well, those are all suspect? Well, the nice thing about yokes is, I don't use them in aerospace. Why am I talking about it? Because you want a level 1 or 2 certificate of training, right? So
Training on things that we can't use?
it's all part of it. That's all part of the certificate.
Probably can use your NDT cert for a lot of things then.
Yes,
not
you
just
can.
aerospace.
That is correct.
Oil and gas, baby.
All right, permanent magnets. Let's see. Easiest way to say it, they work just like a yoke without an on-off button. Would they be AC or DC? If you have to think about that one, we need to talk. But for those of you who did have to think about it, are they AC or DC?
DC.
Why are they DC?
How do you turn them off and on again?
Pick them up, put them down.
Because it's literally a magnet. It does not reverse polarity.
Aren't you saying it does? Doesn't mean that Earth does reverse polarity?
You're like trying to do
Every
Permanent magnets?
60,000 years.
Yeah, no, they seem to say that the Earth like reverses.
Oh, he's got
So
a
it
good
is
point.
AC. It's just like a crazy long.
Yes,
period.
every 60,000 years they might reverse. So,
How many really slow.
Yeah, really slow.
so there'll be a period where my great-great-grandchildren will have magnets that won't work because they're in the reversing stage. It's like, oh, it doesn't
The
work.
cables are for you
Yeah.
twist them all together, and then it spins.
Just like a yoke set on DC, right? But are permanent. But use permanent
Just like my feet.
magnets. Process control on that. What would be our process control? PC, process control. We'd have to check light, right? So if it's visible, we need a minimum of
1,000
1,000 lux or 100 foot candles. We would have to do dead weight check. With how much?
Probably the same thing.
It said it right in there.
30 pounds.
30 at
pounds,
2 to
2
4, 50 at
50,
4 to 6.
more than 46.
30 pounds at 2.
Permanent magnets are not to be used for magnetic particle inspection unless specifically authorized by the contracting agency. When permanent magnets are used, adequate magnetic field strength shall be established in accordance with that.
Now we gotta go find that.
Yeah. How often do you use permanent?
7154. 7154. 71.
Who specifies that?
Refer to next
should know.
Shed weight check.
Yokes and
Yokes, permanent magnets, when allowed, shall be dead weight tested in with alternating yokes.
Oh, what do you know? Same thing.
Yeah.
See, they do have alternating.
Oh, there does. So yokes and permanent magnets.
I think the when allowed is.
Dude. Yeah, alternating current yokes have a listing force of 10 pounds. Direct current yokes have a listing force of 30 pounds. Does not specifically say anything about what the permanent magnet is.
Well, wouldn't that just be a direct current yoke, right? For that?
Since they are.
Yes,
basically
yes,
the
it's
same.
absolutely not going to be the alternate AC yoke for obvious reasons. So, listing force of it, I'd say at least 30 pounds, 2 to 4 inch spacing,
You ever had to NDT something?
and you're not going to get 4 to 6. What?
You ever had to NDT stuff with permanent magnets?
No, it's not allowed unless specific. Not allowed. See, when allowed, and it wasn't allowed.
Who allows it?
Magnets are
The contractor.
What?
Check for damage on the magnets.
Yeah, cracks and stuff.
So you NDT them.
But mostly it's the lift test.
Whoa. How do you magnetic particle inspection?